Hello, this is Mr. Miller, and welcome to this short video on the method of elimination. This is a method for solving a system of equations. It's really powerful and will get you through almost all the SAT problems of this type. Here's our first example. We have two equations and two variables, x and y. And we're going to transform the equations in a way that makes the x terms the same. And then we're going to see how this method works. So, the coefficient of x in the first equation is 9. That's why I'm going to multiply the entire equation by, like that. We're going to multiply the entire second equation by 9. The coefficient of the second equation, the coefficient of x that is 7. We're going to multiply the first equation by that. Okay, so the first equation by 7, the second equation by 9, and we get a new system of equations. We get 63x plus 21y equals 21. And then when we do this multiplication, we get 63x minus 72y equals negative 72. Now, you notice that by doing this, we made the x terms the same in both equations. So, if we subtract them, we're going to eliminate x. So, we're going to subtract the equations. 63x minus 63x is 0. I'm not going to write anything for that. 21y minus a negative 72y. We got to be careful here. We're doing 21y minus a negative 72y. Subtracting a negative, same as adding a positive. Alright, so when you do that, 21 minus a negative 72, you get 93y. And 21 minus a negative 72 is positive 93 again. So you got to remember, we're subtracting the equations. Okay, now we solve for y. We have an equation that only has y, and usually they're pretty quick to solve. I'm going to divide both sides by 93, and I get y equals 1. That's part of the solution. What we're going to do is we're going to go back to one of the original equations. I'm going to use the first one, and we put in y equals 1. So we get 9x plus 3 times 1 equals 3. And then we just solve this. I'm going to simplify it. I'm going to subtract 3 from both sides. You get 9x equals 0. Then I'm going to divide by 9. You get x equals 0. Those are the two coordinates of our point. So our solution is the ordered pair 0, 1. That's the final answer. And if you're not sure, you can always go back, put it into the equations, and make sure it works. All right, let's do another example. So I'm going to eliminate x this time also. I'm going to multiply the first equation by negative 8. And the whole second equation by 3. So we're going to get negative 24x minus 40y equals negative 8 times negative 19 is 152. And here we're going to get minus 24x minus 18y equals 42. X coordinates are equal, so when we subtract them, it should be 0. Negative 24 minus a negative 24, same as negative 24 plus 24, which is 0. Alright, negative 40y minus a negative 18y is negative 22y. And 152 minus 42 is 110. Okay. We're going to solve that for y, and we get y equals to negative 5. Okay, so we're going to go in. You can use either equation. I use the first one. We're going to put negative 5 in for y, and we get 3x plus 5 times negative 5 equals negative 19. Or 3x minus 25 is negative 19. So we get 3x is 6. If we add 25 to both sides, we get x equals 2. So our solution is x equals 2, y equals negative 5. Sometimes you can eliminate y if you want to. So I just wanted to do one here where we eliminated y. So the coefficient of y here is 3. So we're going to multiply the second equation by 3. Coefficient of y here is 10. So we're going to multiply the first one by 10. We should see that the y terms are equal this time. So we get 40x plus 30y equals 70. Negative 9x plus 30y equals 21. We're going to subtract 40x minus a negative 9x is 49x. The y's cancel. 70 minus 21 is 49. It turns out you get x equals 1. All right, let's plug it in. So we're going to plug in for x this time. 4 times 1 plus 3y equals 7. 3y equals 3. Or it turns out y is 1 also. So we get the point 1, 1. That's our final solution. All right, there's just one last thing I want to talk to you about, and that's sometimes the system is not ready to solve yet. Sometimes all the terms are out of order, and we have to write it in standard form first. I want to remind you that if you move a term to the other side of the equation, you change its sign. So we kind of want to swap everything here. When I move 4x to the left side, we get 4x. When I move minus 5y to the left side, I get plus 5y. If I move the 7 over here, we get minus 7. All right, on this one, I see the 5x is okay. I want to move the minus 7y to the other side, so that's plus 7y. The negative 5 is fine. It's on the right-hand side. So pretty much I want the x and y terms on the left and the constants on the right. If they're already there, we don't have to move them. Okay, and now we can do what we were just doing. I'm going to multiply the first one by 5. I'm going to eliminate x this time. And this one by 4. And we get 20x plus 25y is minus 35. On this one, we get 20x plus 28y is negative 20. And when we subtract, we get negative 3y equals negative 15, or y equals 5. And if you go back and plug in, you can use either equation, but I use the second one. We would have 5x equals minus 5 minus 7 times y, or 5x equals negative 40, or x equals negative 8. So the solution is negative 8, comma 5. All right, that was pretty fast, but there's 4 good examples. If you have those, you're set to do a lot of great math. All right. You should be ready to go on and complete activity 0130 in Google Classroom, the method of elimination, and good luck. Always contact me if you have questions. Take care.